Hey guys and gals. Hey guys and gals. How you doing? How are you doing? How are you doing? Let's go. Let's go. Appreciate you being here. Hitting that play button. Let's go. Turning you guys and gals up. Getting you pumped up. Getting you ready and set. Let's go. Do some mathematics. Oh yeah. You know you love it. You know you love it. Making it easy over here for you guys and gals. It truly, the idea, the concept, the main goal is to kind of just simplify things, just so that you guys have a new outlook, I guess, if you will, on mathematics and not look at it like it's hard or anything. We're gonna make it easy over here. Let's go! Because math is fun. Yes. I use mathematics. I'm older, right? So I do it. It keeps the brain fresh. Fresh! The brain is fresh. Yes. I have other reasons behind it and other thoughts and analogies, but we're just gonna keep it to mathematics over here. Let's go. Appreciate you being here. This is for you parents that are homeschooling their children, their childs, their kids. Here to support. I am assuming that you have a lot on your plate, probably full. So here to help. Here to help. If I could help you alleviate some of that stress and feeling overwhelmed or overburdened, I hope that I can help you. Again, you are appreciated over here. Same thing with students as well. You're welcome as well, students. Maybe you're going to public school or whatever, wherever you are. It's none of my business, to be honest. And but definitely glad that you are here and you found the channel. I'm getting a little soft. It actually, feels warm and cuddly inside knowing that you're here and you found the channel and you're watching, and this is great. I love it. So yeah, giving you guys and gals, tips and tricks and my advice and my experience and shortcuts and what else not to help you excel and just smash math. You're smashing it. Again, you definitely are welcome over here. Welcome to the 120 and higher IQ club. Let's go! All right, time to work. Let's get some work done. Sticking to the topic, because that's what we're doing over here. Mathematics. Oh, yeah. All right, I left you guys and gals with this little, key ideas, I guess. Something for you to read. We got intersecting lines. We have opposite and adjacent angles. We have congruent angles. What else do we have here? A and B and on the right, blah, blah, blah. We haven't. I was kind of reading all this, but we'll just skip past that. We kind of been over a lot of this. Hopefully you've been following the series and you know what's up, which is great. We have two line segments intersecting each other at 90 degrees. That's the symbol for 90 degrees. Anytime you see that, you'll see that as well in right triangles. That means 90 degrees, boys and girls. 90 degrees. Okay, lines that do not meet are called parallel lines, so they run parallel with each other. Just think of two vehicles driving down the highway or the roadway in the same direction, side by side, without intersecting each other, and they're just driving down the road, same direction, same speed or whatever. Basically, they'd be running down the roadway in a parallel fashion. Okay. Here's an example right here. Two parallel lines. Okay, this one and this one. Okay, the way I kind of teach this over here, I don't know, they got this weird Z pattern concept. Like, I don't even know why that even matters. It's not even really that. It's kind of silly to me. But really, what you need to visualize is so we have alternating angles and all this sort of information going on. There are interior angles, which is true. To me, they're kind of opposite each other. What's the this is the only part that I kind of like. For me, it's not so critical to understand. They're obviously opposite. You have corresponding angles, you have alternate interior angles, you have same side interior angles. I mean, we could quickly kind of go over that. I think, like, I don't want to spend a lot of time on it. We've already talked about it a little bit. These are examples of alternate angles. They're alternate from each other. Alternate. But they're also congruent as well. Congruent meaning they're the same value in angle, in degrees, right? Trying to get my words out today. Same thing here. Okay? Alternate. So yeah, I don't really focus on the alternate terminology so much. For me, it's more so seeing that these are acute angles, which equals, in my mind, they're the exact same value in degrees. This is an obtuse angle. This is also an obtuse angle. So they're alternate of each other, which in turn also means that they're congruent as well. Okay, so I'm going to leave it at that because I'm not so focused on that terminology more than seeing that are they acute. If they're both acute angles, we have this kind of situation where you have two parallel lines and a transversal line. Okay, that's kind of what we're talking about here, guys and gals. Okay, opposite, and then adjacent, well, basically they're just neighbors to each other. Hopefully that kind of made sense. Let's see, hold up. I don't want to leave you guys and gals too much in the dark here, right? Here we go. Adjacent angles. 1 and 2 are adjacent to each other. 1 and 3 are opposite each other. It's really all we need to really know. I'm not too super focused on what's that other term? Is it the same thing? I think it's still adjacent, but you get the idea, right? Okay. Without overcomplicating it, let's keep going. Okay, zoom it back up. So again, like I'm saying here, right? You can see these are acute, right? An acute angle, bring this up again, right? Acute, less than 90 degrees. Obtuse, greater than 90 degrees. And then you're going to see straight line as well, which measures exactly 180 degrees. Again, you're going to have an acute angle and an obtuse angle. Together, you add them together, they'll add up to 180 degrees, right? So, with that said, you can see that this is an acute angle, this is an acute angle, therefore equals, they're both going to have the same value, okay? A equals B, which is true. Corresponding angles, right? Same thing. So we have two parallel lines, or two rays. We have a transversal line, right? But we can also see that they're slightly an obtuse angle, right? Greater than 90. They're going to be exactly the same thing. A and B are going to be exactly the same. Okay, same side interior angles. Same side interior interior. If two parallel lines are cut by a transversal, this is the transversal, right? Parallel lines. Then each pair of interior angles on the same side of the transversal add up to 180 degrees, which is true. Oh, this is slightly... Yeah, this is an acute and this is an obtuse. And that's kind of what I was saying. You have an acute angle and you have an obtuse. You add them together, they should, technically speaking, add up to 180 degrees. All right, let's get into some problems here. Okay, so I'm going to try, I guess we'll just try to start drawing and doing some work here. I'm going to try to draw straight lines, do my best here. Okay, so we have 23 degrees, so I'm just going to exaggerate it. Okay, so right here we have an angle. And I'm just going to go like this. Degrees. Okay, so the other thing when you were working on problems, take note of the little things, right? Oh, look, we have this little box, right? What does the box mean? The box means 90 degrees. For me, this is the fun part, doing all the writing. So now that we know that, we have an angle, we have another angle. We can figure out this. This one's unknown, right? I'm just going to go like that. And we could give it a symbol. Let's see if I can find that symbol. I saved some symbols I wanted to share with you guys and gals. Here we go. This is it here. Okay? So some common ones I'll use is alpha, or beta, or theta. I kind of drew theta a little bit different. Theta kind of looked like phi, but phi, I usually go like this. This is what I'm used to. I've been calling that theta, but really it's not theta. You see the lines on the inside. Lambda is another one. Mu is actually a symbol for something else, like a coefficient. This has to do with friction, so don't use that one. But for angles, theta, beta, pi you can't use. Maybe you could use phi here, phi, theta, beta, or maybe lambda. I guess it just depends on what you want to use. Okay. So I'll just draw this one. It's good enough. It's kind of what I'm used to drawing anyways. So this is equal question mark. Okay, so to figure that out, all we need is a little formula. Now that we have a symbol, we'll use the symbol. That equals, let me just fix that up. Okay, that equals, take your larger one, which is your 90 degrees, and subtract the other one, which is known. You could give it a symbol as well. We could call it beta. Uh, 23 degrees. So those are our knowns. So we could just go like this. So now you actually created yourself a little formula, right? Why not? You could do this. And then now it's just a matter of substituting. Real simple, guys, right? This is pretty easy, right? Again, I believe in you guys and gals. You could do this, right? Don't let it overcomplicate you too much, right? It's just lines and circles and shapes and arrows and such that we're drawing here. Nothing too critical. Okay, and some symbols, right? You just gotta sort it in your mind. Oh, well, this symbol just means theta. We just need something to represent this interior angle, right? That's all we're doing. Instead of using a question mark, let's use a symbol. Okay, so doing the quick math, I guess I could do it right here. Normally, I mean, you could use your calculator, but I don't mind showing you guys the long subtraction. Maybe you got a little lazy with the subtraction. I mean, it's not, I'm not saying it is a bad thing. I mean, we all kind of get lazy at doing it. I like it. I like to do it just to keep the mind fresh. Keep it fresh. I'm avoiding that full timers, you know? Do mathematics when you're young. Love it. Enjoy it. Hug it. Kiss it. Absorb it. Love it. And then when you get older and you're bored and you have nothing to do, you do mathematics. And guess what? You're keeping the mind fresh. Yes, and you're avoiding that long timers. Okay, we're going to borrow from the 9, which makes this 10. Okay, 10. The reason I did that, guys, is because this number here, if I undo, okay, this number here is less than the bottom number. This number needs to be larger than this number in order to straight subtract. But because it's smaller, we have to borrow. Okay? That's why. Okay, so 10 take away 3 is 7. Remember I was showing you guys and gals this? These are our matching numbers, right? If you want to add numbers quickly in your head, just remember this. 6 and 4. No, sorry. 5 and 5. 6 and 4. 7 and 3. 8 and 2. A lot of these you guys will already know, right? And 9 and 1, right? You could do quick math in your head, just knowing the main common ones. Okay? And they all add up to 10, right? So, what goes with 3? Well, 7 and 3, right? I don't even have to think. I know them. I know the matching numbers. Okay, and then 8 take away 2. Well, it just goes backwards 2 jumps. 7, 6. 67. So that should be our answer. 67 degrees. Okay, let's drop the yays because why not? I almost wish I drew that earlier because now I have to erase everything. I guess I could have. I'll just see how far back I could go. I guess I'm just gonna use my regular eraser here. So maybe I'll keep the symbols here too, just in case we need them again. Alright, bear with me while I erase this. I want to save this because I know I write this down a lot, so this is why I'm not having to do it all the time. I might actually put it in here so that I don't, accidentally erase it. I could put it into a different layer. Alright, guys and gals, I should have kept my lines, but that's okay. That's okay. Appreciate your patience while I do this. It's faster to undo. Okay, good. All right. Let's carry on. We'll save that quickly. Okay, so what do we have next? So that was pretty easy, right? So basically, they're giving us a couple of examples here. What you need to know is realize right off the get-go is, oh, this is a 90-degree angle. Quick math, 90 subtract 23 gives us x. Now, same thing with here, right? You got to immediately see that this is a straight angle, right? Even though in our mind it's a line segment, it's a straight line, but it's also called a straight angle, okay, which adds up to 180 degrees, right? So therefore, we can figure out x based on 180 degrees. So let's just quickly draw it. Guess I should go up here. I want to save some room for working here. Okay, and we'll just go like that. We'll just kind of try to draw it somewhat similar. Okay. Again, I could go like this. Whoa. Wow. Right? I know that's 180 degrees. Okay, so they give us 144. So this is known, which we'll call theta. We'll just call it theta. Or beta. I guess I'll be consistent. Call it beta because that's what I did for the last one. And then this one's theta, which is unknown, right? So beta is 144 degrees. So therefore, theta equals 180 degrees. Subtract beta. Okay, which equals 180 subtract 144 degrees. Just double check to make sure you're using the right value. I could have used x. It's fine, guys. Just take note that theta is x, right? That's all. And so that's going to equal appreciate you being here and watching. That's so awesome of you. Truly is. Okay, so I'm going to borrow again, right? Because 0 is less than 4. So we have to borrow and make this 10. There we go. What makes 10 with 4? Well, that's 6 and 4. Quick math. And 7 take away 4 is 3. So I could go 4, 5, 6, 7. I used to use dots to count when I was kind of learning, when I was a lot younger. I'll either use 2 dots to count or 3 dots to count. And then I'll repeat, like I'll go 1, 2, 3, 4, 5, 6, 7, 8, 9. Or if it's even numbers, I'll go 1, 2, 3, 4, 5, 6. Little tricks, that's all. 7 take away 4 is 3. Obviously 1 take away 1 is 0, right? If you have $1 and you gave somebody $1, well, you basically have no more dollars. No more doll hairs. So theta, or x, is 36 degrees. Okay, look at our problem. There we go. Okay, so we can't use a protractor here. I don't know. I scan this for basically this stuff. When most people say the phrase similar to, they mean a little bit like. In geometry, the word similar has a more precise definition. The two triangles similar. What are similar triangles? Well, I'll do a definition again. What are similar triangles in geometry? Yes, I did. Okay. In geometry, similar triangles are triangles that have the same shape but not necessarily the same size, right? So let's see if I can find something that's going to be visual. So this is the scaling concept, right? Scaling. I call it scaling because this is kind of what I've brought up. So you can see this triangle is smaller than this. So if you scaled it, we could say this triangle is 2 times larger than this one, for example. It could be 1.5 times, I don't know. But that doesn't, because you scale something, doesn't change the angles. Okay, that's why there's still similar triangles. So which means in turn that this angle inside here, I wish I could make it bigger, but I can't. That means this angle inside here is going to be exactly the same. They're still going to be congruent. Just because you scale something doesn't mean that the angles change. They don't. Okay? Just to be clear. So, like, for example here, right? This is kind of a good example. I'm just bringing up some quick images. Whoops, I don't want to save. Keep doing that. Right? So we have basically the triangles are mirrored image, but they're not the same size. So they're kind of mirrored. One just got scaled down. But essentially, the only thing that changes is the lengths. Okay, it looks like it's twice as much by the looks of this. If I wanted to, if I know that this is twice this, that must mean that these are all going to be doubled as well. I could do the math to figure it out, but pretty good chance that they're going to be the same. If this side is the same as this side, I could just tell. I could rotate it. Right, this would be the pivot point. I could rotate it. It'll fit right here, and you'll see a horizontal line somewhere around here. As you can see, these are opposite angles, which means they're going to be exactly the same in degrees, in value. Okay? And then green, you can see, look, if I rotated this about this pivot point, you can see the green one is here, and this one is down here. They're going to still be exactly the same angle, guys. All right, so that's similar triangles. Okay, so just think scaling. Nothing changes. If you scale something, I know this from AutoCAD, you can scale something and it doesn't change the interior angles, okay? All right. A polygon is a closed figure formed by line segments called sides. The sides meet but do not cross. Okay? The point where two sides meet is called a vertex. So I imagine what they're talking about is the point, the intersection point. The 3 figures shown on the right are polygons. Okay? These 3, okay, they're talking about. The figures shown on the right are not polygons. Okay, now, so that we could kind of answer why they're not. Well, one, right, the main thing about a polygon is it's a closed figure formed by line segments called sides, but the sides meet the sides meet but do not cross. Okay, so right here you can see these lines cross. That automatically tells you, okay, it's not a polygon. Closed figure, right? This is not a closed figure. You can see that it's open. These are all closed figures, meaning all, you know, every edge or side has a line to it. The point where two sides meet is called a vertex. Vertex, vertex, vertex. This is a half circle here, so really there is no vertex, right? Right? That's why they wrote curved. Similar polygons. Here we go. So here's the same example. We have the original triangle. Let's say I copied this. Like you could do that kind of stuff in AutoCAD. I could copy this and then scale it. And then just because I scaled it, made it bigger or smaller, the angles, the interior angles do not change. They remain consistent. Okay? They do not change in value. All right? So that's kind of the key thing to take notes of. If they're similar, they're going to have the exact same angles. All right. So this is all the same concept, guys and gals, okay? We've already done two like this, right? If I scroll up, here's a 90, here's a straight line. I'm going to leave these for you guys, just for your own practice, right? I'll quickly give you the answer for A and B, just so you have it. Okay, 68. $53. Okay, that's done. All right. So here we go. So they're trying to challenge us a little bit, right? All they're really doing here, guys, is just trying to get you to think a little bit. That's all. It's honestly like, if you don't get afraid of it, just look at it and go, okay, what do we know? What do I know about this? What they're trying to do to me here? What are they trying to do to me here? Well, first off, you could go, oh, I see a box. Oh, that tells me that's 90-degree angle. Okay, so now if I scroll back up here, back to, I'm looking for right here. Remember before? Okay, so commonly complementary angles, you're going to have two angles, okay, that add up to 90, okay? Supplementary can have two or three, maybe four, I don't know, but two, let's just go with 2 and 3. So just take note. Supplementary angles can have anywhere up to 3 angles that add up to a sum of 180. Okay? Right here's an example. A triangle. These are all supplementary angles. So we have 1, 2, 3 interior angles, which all add up to 180. Okay? Just little things to remember. Okay, guys and gals? So here we go. So we have a straight line or a straight angle. As soon as you say to yourself straight angle, think 180 degrees. That easy. And then here they're showing, oh, well, I have a 90-degree angle. Okay? A lot of you probably already have it figured out. So, but let's do the math, okay? Let me clean up here. Okay. All right, so I'm going to try to redraw this the best that I can. I'm going to try. It's not going to be perfect, but I'm going to try. Okay, guys? Okay, there we go. All right, and then we could pretend this is a line segment. Right, doesn't matter. So right here, you know, a straight line. 180 degrees. Am I going to have room for doing the work? I hope so. Okay. Straight line or a straight angle, think 180 degrees. Okay. I'm going to clear that up because I think I'm going to need the room here for working. I should probably go a little higher with this or just remove this entirely so that I could have the room. I might have drew this a little bit too big, but I wanted you guys and gals to have a good visual representation. And this is something I want you to get used to, right? All right. Okay. Again, I could pretend this is X right here. I could pretend. Nothing wrong with me pretending that's X and negative X. Okay? Unless they give you extra information. I don't know. Okay. So right here, let's continue. So they have X. Okay? So if you have X and X, remember, guys, this means that they're both going to be the same in value. Okay? If you have X and Y, well, there's possibility that they might be different in angle. It just depends if this 90-degree angle is rotated a little bit, right? But it's actually perfectly, this must mean this is at a perfect 45. I say this because I know half of 90 is 45, which is, common, right? Something common that you see. I already think that just from my experience, the answer is going to be 45. I got to get rid of that X because I don't want you guys to get confused with it. It's not perfect, but there you go. We have X and X. All right. So we have, basically, we have the 180 degree line segment, right? Which is this. We have the 90 degree, so we got to subtract that. Okay, and then X is basically going to be, I think we could actually work it like this. A lot of people would do it this way. 2X equals 180 minus, yeah, that would still work out. It would still work out. So 180 minus 90, right? Because we have two X's. And so let's continue the work, which equals, so 2X equals, I know this is half of 180 is 90, right? Because you guys know this too, right? If you ignore the zeros, just ignore the zeros. You know 9 plus 9 is 18, right? All right. Like I say, consistently say to you guys, math has patterns. Math is consistent. There's patterns in math, right? It doesn't matter if I have, however many zeros. It doesn't even matter. 9 still goes into that, no matter how many zeros I have. Okay? And as a matter of fact, I could go, how many zeros do we have there? So we have 18 million, right? Boy, that would be nice right now. So I could go like this. Match the zeros, and there's no reason to overcomplicate this in the mind. This is my suggestion, one of my tips for you guys. Just ignore the zeros. Just pretend they're not even there. Literally, if you're reducing or factoring, you can cancel. You have to cancel the exact same number of zeros. Look what you're left with. 18 and 9. All these don't mean nothing. You could go 18 million divided by 9 million. You're still going to end up with 2. Right? Okay. So that's my point. So now we have to do, again, there's two ways to do it. I say the easiest way is we need to make x equal to 1. So basically 1x, right? Even though we just write a variable, guys, even though we write it as just x, it still has a value, and that value is 1. Okay, we just don't write it. It's an imaginary 1. Okay, so we need x to be 1. Well, it's the simplest way to look at it is just take the 2 and go like this. Stick it underneath. So x equals 90 divided by 2. It's always underneath, guys. When you move it from here, it's underneath. Okay? Or to show you the work, a lot of people will just multiply by 1/2. It's still the same thing, but what you do to one side, you have to do to the other side. This is kind of overcomplicating it. A lot of people see this and just want to run away. That's just, don't do that. Whoever's teaching you that, don't listen to them. They're complicating it. They're trying to look, I don't know if they're trying to look like they're more intelligent or smarter, but really they're just making it harder for you to understand. They're not, like, that's not the right way to teach anybody. As far as I'm concerned, like, what exactly is their goal? To make sure you fail? If that's what they're doing, they suck. I'm just telling you. Keep it simplistic. Just go like this, okay? Control Z. So we have 2x equals 90. We just want it to be x. X equals 90 divided by 2. There you go. That easy. You don't even have to show any other work. All we did was took the 2 and put it underneath. Okay, again, math is consistent. Trust. All right, so basically x is going to equal 45. Because I know that half of 90 degrees is 45. And I can show you the work. We could take 90. What does 90 equal? So what's the closest to 90? Well, that's 80. Oh, okay, so that's 40 plus 40. How much more do we need to get to 90? Oh, we need 10 more. Okay, so 40 plus 40 plus 10 equals 90. Okay, all right, cool. All right, let's split this 10 into 2 5s. All right, so I'm going to take this 5, add it to that 5. I'm going to take this, 40, take this 5, add it to this 40, take this 5, add it to this 40. Oh, look, lo and behold, because we only want 2 numbers, right? This gets canceled, these get added, and we're left with 45 plus 45, which equals 90. This also equaled 90 as well. Simple, right? Just split it. That's how you do. It's kind of like mental math in your head. I'm going with even numbers here. I know you could split. You could divide even numbers by 2, right? It doesn't matter what it is. I could have 10 million. I could still divide that by 2. Right? I'm still going to, this is a 10 here. I'm still going to end up with a 5, right? Again, that's part of the pattern. Okay? The zeros are just a bunch of extra things that we wrote on a piece of paper. And again, it'd be nice to have that in the bank account, but, you know. I don't think I'm that lucky. Again, I'm already just struggling trying to make this happen and be successful. I'm doing this for nothing, guys. Okay, my time, sharing my experience, my education with you. Again, I paid my tuition, did the time. I was blessed and lucky. I had instructors. I had really good math instructors. They were awesome. And here's the key thing about my math instructors. They taught math. That was it. Wow, isn't that crazy? Man, it's amazing having instructors that just stick to what they're supposed to do. Crazy. Okay, a lot of people, I know how the world works. A lot of people have the hate for education and that because of the way it is now. I don't blame them, to be honest. Again, in my time, I was lucky. I was blessed. I had instructors that taught. That's why I excelled in mathematics. That's why I excelled in calculus, because I had awesome instructors. All right, leaving it at that. What are we doing for time here? Probably a little longer than we need to be. Yeah, we're getting up there in time. Quick drink of coffee, and we'll try to grind out another problem here quickly. One sec. Oh yeah. Appreciate you being here. All right. How many things do I have open here? What is up? What's this other one? Do I have it open twice? That was weird. Why did it show up twice? That was weird. I'm going to open it again or find it again. Let's see. Okay, go in here. I know where it is. I'm fairly organized with my stuff, so I am looking for Unit 5, Geometry. There we go. Okay, and scrolling. I need to close this. I don't know why I didn't do that last time. That's annoying to me. Okay, where were we? Down here. Okay. I'll just zoom this up just so you can see it a little bit better. All right. Here we go, guys. So we have a triangle, right? Pretty easy, right? You already know what to do, don't you? That's because you are already on the path of becoming, if you're not already, but you're on the path of becoming one of the 120 IQ and above individuals in the world. Let's go. Turn that up. Oh yeah, aren't you excited? You should be, because that's amazing. I don't know. You're part of the 1 percentile, or is that the 5 percentile? So 5% of 1 billion. You're part of the 120 above club. What does that say for the rest of the world? Not very much. I'm on the right, by the way. Okay, back to triangles. Here we go. So same concept. Triangle, supplementary angles. Supplementary equals 180. Sum of 180. Okay, that's what I put in my mind. Complementary, 90. Supplementary, 180. That's all you need to remember. Little mnemonic devices or little things to help you remember. Okay? Again, keep it KISS method. Keep it simple, Stanley. Don't overcomplicate it, right? So all 3 interior angles add up to 180. We're going to use that. That's basically kind of like a formula, but it's not really, but all right, here we go. So same concept. So I could use X, I guess. We'll use X this time. I'm going to erase this because it's just taking up too much of the space. If you've noticed, I've actually went with a larger sheet size, so I had a little bit more room for working. I didn't want to kind of clutter everything in like it was before. I want to make it easy for you guys to see the work. All right. So we'll just kind of try to draw a triangle. Something like that. That's not too bad, I guess. Good enough. Close enough. We'll close it. There we go. All right. 47 and 73. So I could go like this. I like doing this. So I could go like this or like this. Or use symbols. It doesn't matter. 47 degrees. And 73. Now I can see that this 3 adds up to this. So we're going to have a 0. So this 7 and 3 is 10, right? 7 and 3. So this is the unknown, right? And we'll just call that theta, okay? So now I could give these symbols. I could say, I mean, it depends on how fancy you want to get with showing your work. I wouldn't get too fancy when you're doing it in an exam. Again, my tip is you only have a couple of minutes per problem. Some questions, like if it's multiple choice or maybe a problem that you have to work out, some of them you might smash in like 10-20 seconds, right? That's amazing. You just saved yourself a whole bunch of time, right? So that gives you a little bit more time for another problem. So some problems you might need 4 minutes for, right? Again, it's a balancing game, kind of like math. The key thing is you get your exam, and you need to know is how much time do you have? Do you have 60 minutes or do you have 120 minutes? I don't know. That's one thing you want to find out. And then you look at your exam and you go, how many questions are on my exam? Now, if you have 60 minutes to do your exam, and there's 30 questions on your exam, for example, that means you only have 2 minutes per question, okay? Again, little tips. Again, I give you my advice because I was doing really well in chemistry back in, there was a chemistry part in college, and I was doing so good. I had the chemistry stuff all memorized and everything. I figured I was going to ace that exam. But what killed me was the spending too much time on the multiple choice. I wish I had somebody telling me this advice when I was younger. Now, this is all school related and exam related, okay? Nothing else. I'm giving you good advice based on my experience, okay? So by the time, like, all of a sudden I heard, I don't know, something, the teacher say, 5 minutes left or something. And I'm like, what? Are you kidding me? My brain's racing. I'm like, I'm still working on multiple choice, which is ridiculous. Okay, my point is, don't spend too much time on multiple choice. Again, with multiple choice, just do the ones that you know really quick. Multiple choice has 4, right? A, B, C, and D. Get rid of the 2 stupidest answers. Just get rid of them. So you're going to have 2 that are going to be kind of battling between. Which one is correct? Is it A or is it C? Is it B? Is it A? You know what I mean? Do you know what I'm saying? So you get rid of the 2 stupid answers, and you got to figure out the best answer out of the other 2, right? You always pick the best, right? That's how you do multiple choice. Get rid of the 2 stupid ones. I hope you don't mind me saying that word, guys, okay? Silly, the most silliest, ridiculous ones, I guess. And then you figure it out. But again, don't spend too much time on multiple choice is my advice. Because by the time I got to the end of the question, like the end of the test, was all the chemistry formulas. And I was like writing chemistry formulas. I couldn't have written them any faster than I ever did in my life. I didn't get them all written down because I ran out of time. If I didn't spend so much time on the multiple choice, I would have aced that exam. But because I wanted to really ace it, that's why I ended up spending too much time just overthinking each question. Okay? Don't do that. All right? Okay. KISS method, right? Keep it simple, Stanley. Okay, here we go. Let's solve this. Okay. It's not a formula, but I mean, it works, right? A plus B plus C equals 180. Again, it doesn't have to be A, B, and C. It could be C, D, E. It could be anything, right? Variables are interchangeable. Okay, so going back down to here. So X, we'll just say X, Y, and Z, okay? So X plus Y plus Z equals 180, okay? There's our formula. Now I can kind of, so I gotta change this to something else. It's supposed to be X we're solving for, right? X is unknown. X is question mark. Okay, so this is just like any algebra, guys and gals. So we're solving for X. So just like if you've been following along and watching, so we want X on the left side, okay? We're keeping this here. So we have an equal sign here. I call that the fence, okay? And it's a balancing game. Like I always say, I give you guys the teeter-totter concept. This is the equal sign, okay? We have a teeter-totter. This is mathematics 101 here. If you have plus on this side, you're going to have negative on this side, okay? Teeter-totter effect. That's math 101. So whenever you move a variable to the other side of the teeter-totter, it changes the sign. Okay, this is Algebra 101 right here for you guys. Okay, so I'm just going to write the 180 because it's the one that's right beside the equal sign. I'm going to bring Y over and I'm going to bring Z over. Okay, so if you notice, they're both plus signs. This plus sign belongs to this. This plus sign belongs to this. Okay, as soon as you bring it to the other side, that changes the sign to a negative. Same thing with Z, negative. So now it's just substituting. 180, subtract. So I'm going to just call this Y and this Z. Good enough, okay? I could have wrote it up here. I could have went Y equals 47, Z equals 73. Okay, it doesn't really matter. Okay, so 47 and 73. All right, we could do the long math, but I want to just kind of speed this up. Hope you guys and gals don't mind. Right, I could do the long math. I mean by just going like this. I'm gonna have to do it 2 steps. 47. Borrow 1, 3, 7, 3. Okay. So now we're at. What did I do? Oh, bring the 1 down. Okay, we're at 133, and then we have to subtract the 73 still. This becomes 0. I don't really have to borrow. I can't really, but just we're gonna go 13 take away 7. We don't have to borrow. I mean, if I borrow, I'm just gonna be going 0 and putting a 1 there again anyways. So just look at it this 13 take away. I know 7 and 7 is 14. Right? I know 7 and 7 is 14. So therefore 13 is 1 less. That means it's going to be 6. So our answer should be 60. I just did the long, but let's double check it on the calculator. 180 subtract 47 subtract 73. 60 degrees. Let's go. Okay, I'll leave that kind of up there for you to have a look. Let's drop the A's. All right, I think that's it for time. Yeah, we're at that time now. So I have a couple more problems here, guys and gals. Okay. I'll do them next video, but here they are. I would like you to try to work them out and solve for X and solve for Y on E, and then same thing for F. Solve for X and solve for Y. Okay, and then I'll do these ones and then next video. So appreciate you being here. Hopefully you're learning and growing. Again, 120 and higher IQ club, guys. Right? Smarter, better, wiser, stronger. Let's go. Appreciate you being here, parents, childs of the parents, and all students. You guys are welcome. Thank you for being here, watching and learning and growing. I appreciate you, Johnny Whiskey Tango. Sharp, coding, and mathematics. I appreciate you. We'll see you in the next video. Take care for now. Peace!